Hey Opties! Today we're talking about bisectors. I really like the image that is beside this vocabulary term. It's a star, and half of it is colored in and half of it is not colored in. And notice I use the word half. That is a perfect representation of what bisector means. A bisector is when you have a line or a ray or a segment and it cuts something into two equal-sized pieces. Now, this can occur with two different types of things: a segment bisector or an angle bisector. Well, when you're bisecting a segment, you're cutting a segment into two equal-sized pieces. When you are bisecting an angle, you're cutting an angle into two equal-sized pieces. Let's take a look at segment bisectors. So here's a definition. A segment bisector is a line, segment, or ray that cuts a segment into two equal-sized segments. So you're separating it like a segment addition type of situation, but it's special because now your two segments you've created are equal to each other. So that's what a bisector does. It always passes through a special point. So remember when we talked about segment addition, there was some point on the line in between the two endpoints that sectioned the segment into two different pieces. The special point that we're talking about here would be the midpoint of the segment. If the bisector is making two equal-sized pieces, it has to go through the midpoint of the segment to do so. So that's something special about a bisector. Think about this as well. Your original segment has now two different pieces, and each piece or each part is half the size of the total segment. So basically, segment bisecting, that situation is a special situation of segment addition. Let's look at this diagram or this image we have for bisector of a segment. So remember when we are given some information or given info, we always want to fill in that info in our given picture or draw a picture from scratch. So let's do that. Given point P is the midpoint of segment S. Okay, so let's just kind of make a note of that. This is going to be the midpoint. So point P is the midpoint. Line L passes through point P. Okay, we can tell that by looking. There's something we're going to draw here in our picture that is implied when you know that P is the midpoint. We know that AP and PB are equal to each other. Let's write that. AP is equal to PB. We know that because it's being cut straight down the middle through that midpoint by line L. So we're going to also be able to say this. Now here's some new vocab. Segment AP, so we're just declaring it. We're talking about it, not necessarily the length, but the actual segment itself. That's why we're putting the bar on top. Segment AP is congruent. Now notice I put an equal sign and then a squiggle on top. This means congruent. It's congruent to PB. That means they're exactly the same length. Yes, you can say their lengths are equal, but congruent can be applied to different situations like segment lengths or angle measures. So that's a good vocab to know. I'm gonna write real quick that this is congruent. That's our congruent symbol. An equal sign with a little squiggle on top, kind of like a tilde. So if those are congruent, we have these things called congruent markings. We have different markings for segments than we do angles. So let me show you what it looks like when you're marking two segments to be congruent to each other. I'm just making a little tick mark. This tick mark is on AP. If I want to show that PB is the same size or same length as AP, I do the same exact marking on that one. So I've got 2 tick marks and they're the same number of tick marks. I could also do 2 tick marks on this one, AP, and 2 tick marks on this one, PB, and they would still be shown to be congruent as long as the number of tick marks are the same number. This is a symbol for marking that segments are congruent. So let's look at these questions. Is line L a bisector of segment S? How do we know? So we've gone back to looking at this first piece of info here that helps us identify what a bisector is for segments. A segment bisector always passes through the midpoint of the segment it bisects. The size of the new segments are then always half the size of the bisected segment. Okay, so does line L pass through the midpoint? The answer is yes. So yes, it is a bisector. And the reason we know is because line L passes through midpoint P. You could also write the midpoint P or the midpoint point P, but the easiest way is probably just saying midpoint P. And we know that because it's given to us. Both of those are given. It's the midpoint and it passes through P. Let's look at this second question. If so if line L is a bisector of segment S, which it is, what does that suggest about segments AP and PB? We'll look back up at this statement. The size of the new segments are then always half the size of the bisected segment. So there's 2 things we could say. One of them is just the fact that they're congruent. So 1, they are congruent. And I'm not going to write the word, I'm going to draw the symbol because it's a little easier. And the second thing, they are half the length of the total segment, which is segment S. Segment S is written as segment S, and it can also be called AB. Now let's take a look at angle bisectors. This is going to be a specific example of angle addition, just like segment bisectors present a specific example of segment addition. So definition, an angle bisector is a line, segment, or ray that cuts an angle into 2 equal-sized pieces or equal-sized angles. So here's what we know about that. The size of the 2 new angles are then always half the size of the bisected angle. Now, we didn't say anything about the ray that is the bisector or line or segment passing through the vertex of the original segment. That is true, but that doesn't make it be a bisector. Because, for instance, I can draw this segment here. This is just some random segment, right? It passes through the vertex of the original angle, angle A, but you can tell the size of this angle and the size of this angle are definitely not equal to each other. So just because it passes through the vertex of the original angle does not mean that it's a bisector. The way you would know it is a bisector is that it makes the 2 new angles equal to each other or congruent, just 2 different ways of saying the same thing. And also, each of the new angles created are half of the original angle. Let's take a look at our image and our given information. We have angle A as our total angle. Ray R is a ray that is between the sides of angle A. And we have the new angles, angle B and angle C. So that's all we can tell from the picture so far. Let's look at our given information and see what else we know. Given, the measure of angle B is equal to the measure of angle C. Okay, so we know they're equal. That is telling us that ray R is a bisector of angle A. Let's go ahead and write this information in by doing some congruent angle markings. So remember, over here for the segments, we did little tick marks and we made sure that they had the same number of tick marks, both 1 tick mark. If you're trying to show congruency of angles by just looking at symbols or part of your picture, you can draw these little arc marks. We've seen these before, but as long as you have the same number of arc marks, that means they are congruent. Sometimes you will also see people write like this. They'll do an arc mark and then they will use tick marks in the arc marks to show congruence. So that's two different ways to represent it. I'm going to do these tick marks just to show you how it kind of goes along the same way as the congruency marks for the segment. But again, it can be the same number of arc marks or the same number of tick marks on the arc marks. For example, if you had this situation and these two were equivalent, you could have it with 2 arc marks and you would know they are equal. Let's take a look at these questions. Is ray R a bisector of angle A? We just said that it is, and we know that because it satisfies this example here. The size of the 2 new angles are equal, and we know that from our given information. We can say yes, since the measure of angle C equals the measure of angle B. C and B are equal, and it tells us that in our given information. If so if it is a bisector, what does that suggest about angle A and angle C? So we're not talking about angle B and C, we're talking about A and C. Well, we can say 2 different things. One thing we can say is the measure of angle A is double the measure of angle C. And the second thing we can say is the measure of angle C is half the measure of angle A. These are 2 statements that mean the same thing. They're just said a different way. So same thing, different thinking. Let's also write both of these statements in an equation form. So the measure of angle A is, that'd be our equal sign, double, so 2 times the measure of angle C. Another way to write this statement is the measure of angle C is or equals 1/2 the measure of angle A. So that's the relationship. This angle C, it's half of A, and A is double. That is it for bisectors, so our segment bisectors and our angle bisectors. Stay tuned for our next video, which will be practice with this content. See y'all next time.